Hey everyone in meteorology class, my name is Nathan Neely. In science, when I have modeled the Earth's axis rotation and seasons in the past, we've always done a tennis ball globe. That's a pretty cool activity. Then I just take, this is a shish kebab skewer that I'll shove through the middle to kind of to represent the axis of the Earth as we go through. And then it's a pretty cool activity. If the tennis balls are worn, then the globe actually fits better and they can color it. That's a pretty cool thing. And then it also sticks a little bit better with the glue. The other thing I'm using is a flashlight. You can see here as a light source or focused light source. That flashlight will act obviously as our sun, and normally there's not quite as much light as I have here in the room. I'll turn down the lights and I'll shut down the blinds as much as I can and just have a little bit of light. And I'm going to kind of go through and explain some of the things that I normally do when we're describing or teaching the rays of sun and the axis. I'm going to hit this light. So the first thing we talk about is different times of the year and the sunlight and why we have different seasons. With the Earth on its axis tilting away or toward or equidistant from the sun at 23.5 degrees. I describe to the kids usually that, as you can see, as we in the northern hemisphere here are tilted away that 23.5 degrees, that we are a little further away from the sun, and because we are further away from the sun, we have a less of the direct sunlight or the direct energy. If you could visualize or picture the specific or direct angle waves is kind of what I would draw. Sometimes I'll have them take a string or a piece of licorice that they're working with and kind of show different lines or different strands through it. And I mentioned as we are further away, then we have less direct sun, and that is our winter. And then as we're looking down in the southern hemisphere, as the northern hemisphere is tilted away, then that creates their summertime or their warmer, or they get the most direct sunlight. At the two equinoxes, the spring and the autumn equinox, even though we're not directly straight up and down with our axis is not tilting toward or away from the sun, but it's kind of in planar. And at that point, we have a more direct 90-degree access or hit from the sun or the sunlight and its radiation. At that same time, we have almost a 12-hour day, 12-hour night. The days are almost the same. And as we continue through our cycle around the sun, the times when we are leaning now on that 23.5 degree axis toward the sun, in the northern hemisphere, it is our summer, and in the southern hemisphere, it is our winter. And it feels like now here in southern Utah that with our air conditioning breaking down today, that this is definitely, we're way much closer to the sun than I realize and I enjoy. But that's similar to or a sample of how I would model the Earth, its axis, and how we get the different degrees or the different seasons as we are tilting toward the sun. In the northern hemisphere is summer, tilting away in the northern hemisphere is our winter or our cooler moments. And then on the vernal or the spring and the autumn equinox, when we are not tilted away or toward the sun, but more tilted in line, we have more of a 90-degree shift or a greater amount of sunlight and energy that is striking the Earth in our areas at 90 degrees, which is more the spring and the fall. And that's it.